Okay, Algebra II Support. Here is a worksheet. That can help you be able to understand how to evaluate functions. We're going to look at two ways. We're going to look at actually evaluating functions by substituting a number from the domain, and we're also going to look at evaluating functions graphically for a specific domain number. First off, you can see that functions have different names. This one's called f, this one's called g, h, we have j, we have k, we have m. So we have all sorts of different functions that you can plug values into. The first question is wondering what f of 3 is. So what I need to do is f of x, it says, is equal to 3x plus 4. Well, f of 3 will mean that everywhere I saw an x, so I have an x here, I have an x here, I replace it with a 3. So f of 3 is going to be 3 times 3 plus 4. So f of 3 is equal to 3 times 3 is 9, plus 4 is 13. So we just plug that number in wherever you see an x. So g of negative 5, well, g of x is equal to negative 6 minus 5, negative 6x, excuse me, minus 5. So g of negative 5 is going to be equal to negative 6 times negative 5 minus 5. So g of negative 5 is equal to negative 6 times negative 5 is 30, minus 5 is 25. H of 0, h of x is equal to x squared plus 2x minus 7. I plug in a 0, so h of 0 is equal to 0 squared plus 2 times 0 minus 7. 0 squared is 0. 2 times 0 is 0. So we just have negative 7. Letter J. We have j of x is equal to x to the third minus 3x plus 2. So j of 2, I have to plug in 2 for the x's. So 2 to the third power minus 3 times 2 plus 2. Sorry about that. J of 2 then be equal to 2 to the third. It's not 6. 2 times 2 is 4 times 2 is 8. Minus 3 times 2 is 6. Plus 2 is 4. Do 2 more with you. K of x. K of x is equal to the absolute value of 2x minus 9 plus 3. Absolute values take the positive. So if you put in negative 1, k of negative 1 is equal to the absolute value of 2 times negative 1 minus 9 plus 3. So the absolute value of 2 times negative 1 is negative 2 minus 9 plus 3. What's negative 2 minus 9? It's negative 11. What's the absolute value of negative 11? Positive 11. Plus 3 is 14. So 14 is the result. So again, we're just simplifying by plugging in these numbers. Finally, number 6, m of 4. So m is the square root of x minus 3 plus 1. M of x is equal to the square root of x minus 3 plus 1. So m of 4 is equal to the square root of 4 minus 3 plus 1. 4 minus 3 is 1. The square root of 1 is 1. So 1 plus 1 is 2. So that's my function value. So I've done a lot of these problems for you. I want you to continue to do 9 through 14 on the back side. I'd like to do 15, 16, 17, and 18 as well. I'm going to help you with problems 20, 21, and 22. F of 1. Well, that means if I plug in 1 for x, so if x equals 1, what is the y value? That's what that means. So let's look at our f function. If I have an x value of -1, it looks like the output is +4. So 4 is my value. Let's try g of 4. G of 4. So if x is equal to 4, what's the y value? If I plug in 4, the function has a height of 3. So 3 is my value. H of -3. So if I have an x value of -3, what's the y value? Well, if x is -3 for h of x, I plug in -3, I get a value of 4. So 4 is my result. Some of these you could tell that it's not going to be exact. You might have to estimate. So you might have to estimate the result for some of these. Like, for example, h of 2. H of 2. So if x is equal to 2, what is y? If I take this 2 and I plug it in, it looks like my output is about, I don't know, -2.6. But we estimate that. So some of these you might have to estimate. So you can finish off those problems. And the others from the front side, please turn this in by the end of the hour, and we'll talk more about domain and range tomorrow. All right, be great for Mr. Shabluski. He's a good guy.